and start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on Twitch. No engines, no libraries, it's just us and absolutely all the code, with the exception of Windows, which, you know, it gets in our way, it does, but it's the platform you gotta ship on. What can I say? So here we are, writing on top of Windows. Someday, and I hope that day is feasible down the line, we'll work on a platform where we can get rid of the operating system, because that would be really homemade. And you know I'm looking forward to it. But if you're a game developer, there's no getting around the truth. You gotta ship on Windows. It's where all the games are purchased. So if you want to feed your family, you gotta ship there. So here we are shipping here. And we are in the middle of, well, honestly, we're not really in the middle of anything. We did a bunch of optimization stuff, and it was actually very light optimization stuff. I just showed how to do SIMD and then multithreading. We didn't really try to push it too far, but it turned out to actually be extremely fast because processors are extremely fast these days. It was kind of surprising. But we wanted to start to do some other things and kind of push forward into some of the areas that we hadn't quite finished yet, and sort of let that come back around to optimization so that we could really crank things down a little bit more in a separate pass. So right now what we're doing is a little more architecture work. We're just trying to push the renderer a little bit further forward into a state where I feel like I'm comfortable saying this is what it does, and we can probably live with this for the entire project. You know, I mean, we don't have to log it down. We can always go back and add things, but just something that I would reasonably believe you could write all of Handmade Hero in and not be hamstrung or anything. So we're just doing a little bit of that pushing. So it's a little bit helter-skelter, a little bit anything goes for a while here, where we kind of go through and push on all the pieces and get them to line up. And one of the things that we wanted to do was get ground chunks rendering on a separate thread. And there's some things that we have to be able to do that because there's some parts of the engine that we haven't built out yet that are required to do that. And so that's what we're probably going to take a look at today. So let's get started. If you would like to follow along with me at home, please remember today is day 131, which means you want to unzip day 130 source code if you would like to follow along with me. So if you ordered the game on handmadehero.org and downloaded the source code, unzip 130, day 130 zip, that's what I'm starting with right now. Okay, so here we go. Here we go. We had sort of an amusing thing that happened. If you remember at the end of last stream, we were zoomed out here in kind of a looking at things. So if you take a look at what's going on here, there's two things that we wanted to start taking a look at. One is that, you know, you can see that we're doing these ground chunks on demand, right? And the little yellow ring is we're kind of zoomed out for debugging purposes. The yellow rectangle here is where the screen would actually be when we're at normal size, when we're not zoomed out. So that's what the user, that's what the player will actually be seeing is what's in there. And so our goal is obviously to make sure that we always have ground chunks available for the player when they go through there. Now we have a problem. It's not that much of a problem because our renderer is a lot faster now, but you can see we get a slight frame rate hiccup, just a slight one, when we create those new ground chunks, right? And we could fix that in one of two ways, right? One way we could fix that is just by making it a little less brain dead when we create those ground chunks, because right now we're actually doing that in a really stupid way that involves a lot more graphics work than it ought to. But what I'd rather do is I would rather go ahead and multi-thread that, just because I know we're going to want to do some multi-threading of this form where we have things that are working in the background. And so I think it's probably a good time to get something like that working, again, because we are trying to nail down all of our engine stuff, and that is an engine thing. So in order to make sure that our engine is looking like I want it to look before we start doing game stuff, I want to make sure that we've got a few things happening in that overlapped fashion. So what we want to do is we want to start being able to run that on a separate thread, and let's take a look at the reasons why we couldn't do that. Now, the first thing that we need to do is a little bit of cleanup, because we actually didn't do this. And it was total luck that it was working at all. It just so happened that we were aligned. Now, for those of you who don't remember, this pad thing right here is the only thing saving us from faulting. So let's say I compile our code and it doesn't have the pad in it, right? So the pad's not there. I go ahead and run this. You'll notice we go ahead and we get a assertion trigger here. because our memory is not aligned. And of course, if our memory is not aligned, then our optimized rendering code won't work. So the only reason that that was turning out to be true, that our renders could work on the tiles, on those ground chunks, was because they just happened to be aligned. Now we knew the frame buffer was aligned because we made sure the frame buffer was aligned, so that wasn't an issue. But when we go to render to those tile chunks, those ground chunks, those were not aligned. And so what we want to do is make it so that if I don't have this pad in here, because remember the transient state is at the start of the transient buffer, and then we kind of just push things onto that buffer, those ground chunks, where they are alignment-wise, is affected by how big transient state is. Okay? So what we want to do is make it so that we can run it this way and not have this assertion fire, and not have it, of course, crash. Because again, if I commented out that assertion, it's not like it would just work. It would actually just crash a little later on, right? So if I take this out, right, and I run this code, we'll crash when we actually go to do it because this load is an aligned load, and aligned loads will fault if their destination is not actually aligned. And the same would have been true down here for our store. You can see that our store is also an aligned store. Remember, store without a U is aligned store, load without a U. If this were store U, it's unaligned and then it's fine. But we wanted to use those aligned stores and loads. That's the instructions we wanted to use. So we're using those, and that was fine because everything was aligned. And we had other reasons for doing that that had to do with cache contention and race conditions. Hopefully you watched all that. You know why that is. We went through it in a lot of detail. So the first question is, how do we fix this problem? How do we make sure that those tiles are going to be aligned properly? Now we know, right, when we create these ground chunks, so we have our transient stuff here, right? We have our transient stuff. We know when we're calling this make empty bitmap stuff that we probably want to make sure that these things are aligned, but what we don't have is a way to actually make sure they're aligned. So when we go into, say, make empty bitmap here, if we wanted to make sure that this was aligned, we know right here when we do our push size, we could tell the allocator that we needed it to be aligned if only there was a way to do that. And unfortunately, there is no way to do that. But what we can do, obviously, is we can write one. If we go in here and we take a look at push size, let's go ahead up here, push size. What we could do is say, oh, okay, let's go ahead and say that there's another parameter that comes in here, which is just the alignment, which is what kind, what alignment you wanted. How many bytes did you want this to be aligned to? And we'll say this has to be a power of 2, right? And we'll just default it to 4. We'll say that D-word alignment is the default alignment, and that if anything else, if you want any other alignment, then you have to ask for it explicitly. So what I can do then is I can say, all right, we've got our result here. This is what our pointer would be. We've got our base and this stuff here, right? What I want to do now is see if there has to be some kind of adjustment, right? And we've done this code before. We've done alignment code before, right? Because if you remember, when we were actually doing our draw rectangle quickly, we did code that looked a lot like this, right? When we came in here to do our clipping, we did stuff like, oh, is this aligned to 4 pixels? Remember, that's the way we were doing this here. Is this aligned to 4 pixels? If it's not aligned to 4 pixels, and we were doing and 3 there, like remember, and 3 has the 2 bottom bits set, right? The 1 bit and the 2 bit. Add them together, you get 3. That's what 3 is. It's the 2 bottom bits are set. So we're saying, are either of the 2 bottom bits set? If they are, then this thing ain't aligned to 4, right? Because anything aligned to 4 will have both bottom bits as 0. So we'll go ahead and check those, and we'll do something about it if they're not there, right? So that's what we want to do. And specifically, we want to move up, because remember, we can't move backwards to align because that would move into memory that's already being used. So we need to move upwards to put us at the next boundary. So what I want to do is say, oh, okay, we've got this arena base, right? So we can say this alignment that we have here, we can say, we can do exactly the thing we were doing before, right? We can say that if that, I guess I should explain this part a little bit. We'll make an alignment mask here. And I don't know if we've gone over this before. I think I've done it before, but I don't know if I really actually talked about it explicitly. So I'll just go ahead and draw it real quick, since this is the first time maybe that we're really talking about it in a memory context explicitly. But if you have some binary number, right? In this case, let's say I want to align to that 4, right? Well, hopefully you guys all remember your binary here. So here's a byte. Let's just do a byte. Remember what the bit's in. This is the 1-bit, 2-bit, 4-bit, 8-bit, 16-bit, 32-bit, 64-bit, and the 128-bit, right? So if all of them are set, you'd add them all together, you'd get 255, which is the maximum a byte can store, right? And if you add any other combination together, you can produce any other number between 0 and 255. So if you come in and you see something set as 4, then you would expect to see this, right? The 4-bit is set, and the other bits are not set. So now, if we want to know if a given value is aligned to 4-byte boundaries, and we're saying that that means that these have to be 0, right? What we're looking for is a mask that allows us to test to see if these bytes are set. And a trivial way we can do that for a power of 2 is by subtracting 1 from the value. Because if we subtract 1, right, what will happen is this will turn into a 1, this will turn into a 1, and this will turn into a 0, right? It will borrow over, 100 minus 1, where each of these is binary. It will keep borrowing from itself. It had to borrow, a 2, right? It had to borrow, again, a 2, and then it borrowed. And so you end up with the 100 minus 001 equals, right, 011. It's analogous to how you do it in decimal, but unfortunately it's hard to imagine because normally if I do this, right, you would think of me doing 100 minus 1. You're thinking of going like, oh, okay, I've got to borrow, this way. I'm borrowing this and turning this into a 10 or something like that, right? But of course, in this case, the highest number you can actually have is a 1 in a column, so borrowing something from the next one just gives you a 2. I don't know if that makes any sense. Probably doesn't. I know it's a little bit confusing, but hopefully you understand what I'm talking about in binary. You can also see that this makes sense logically. If I have 4 and I subtract 1 from it, I would expect to get 3, right? And of course 3 is the bottom 2-bit set, 1 and 1, right? So hopefully you can also see that that just makes sense logically just in terms of the encoding. Even if you're uncomfortable of doing the math in binary, you can see that it works just in decimal and then if you re-encode it back. So all we have to do to take a power of 2 and turn it into a mask is just subtract 1 from it, and that will produce the mask of the bits that should not be set if we're aligned to it. So what we can do here is say, okay, if we have a situation where the base pointer is not aligned to the alignment mask, the first thing that we do is we can push up that alignment, right? And the way that we'll do that is I'll say, okay, I've got a memory index, which is my alignment offset. And at the end of this whole situation, what I will actually do is I will take the arena base and I will do the arena base plus the alignment offset. There we go. So the arena base plus the arena used. Oh, you know what? I actually have to look at arena used as well. All right. So I've got to actually do this a little more slyly here because I have to, the way that we've encoded this has to go this way. All right. So let's talk about basically the pointer, the result pointer. All right. So if we take a look at what happens here, this is the base pointer for the arena. This is how many bytes have been used. And so if I add those two together, right, I get what the actual result pointer will be. And so what I want to do now is make sure that I can actually align that so that, you know, the result will be aligned to the value that we passed in. So I've produced that alignment mask, and these are the bits that I know can't be set. I take a look to see if any of them are set. If they are set, what I want to do is I want to go ahead and move up however many it would take me to produce the alignment, right? So the way I'll do that is I'll just say, oh, okay. Excuse me. I'll just say the alignment offset is going to be whatever the alignment was, right? Because if I was at 0, I'd add the whole thing, minus whatever sort of that, oops, minus whatever portion of it we've already gone, right? So I want to go the whole way to the alignment, and I'm just going to take whatever portion of it we found there. I'm going to go ahead and subtract that away, right? So that's the offset that we would need to add. So what I want to do here is then say, okay, the size that they requested, I now have to assume that I want that size to be inflated by however much I need to align. Because remember, we're trying to make sure that we have enough room in the buffer. We need to include however much motion we're doing for that alignment so that we can properly track the size. So we go ahead and move the size up there. We then assert to make sure that we have still room in our arena, because remember, we don't allocate any more space currently. We just use the space that we have. So if anyone overflows that, that means we've hit an error condition and things are very bad. And so then off we go, right? So when we do this, our result pointer then, the actual result value is just going to be the result pointer plus the alignment offset, right? And that's going to be turned into a void pointer. There we go. What are you complaining about? Arena base. Ah, yes, right. Sorry, forgot to change that into result pointer. There we go. And result pointer. Okay, so just going over this one more time, and we could make this a little bit more efficient, but we don't necessarily care a huge amount how efficient this particular routine is, at least not at the moment. So again, we just want to take a look at where we would put this thing. This is the current location that it would go. We want to make sure that we can actually align it. So we say, okay, if there is some residual there, if it's not aligned, see how much we'd have to add to bring it up to alignment, right? We then increase the size by that much. And then we just do our assertion to make sure that we can fit that in here. We then add in that new amount as the amount that's actually used in the arena, and we return that pointer. So we can go ahead and run that, although I probably should step through that routine just to maybe show you what's happening in the actual binary code. I feel like we're probably still building in O2. Let's switch, just downshift to debug here. Okay, so here we are in push size, right? And if we take a look at what that result pointer would be, right? Here's the result pointer. I'm going to go ahead and also show here. There we go. There's that result pointer. And I'm going to also show the memory arena, right? So you can see this is how big it is. We haven't used any of it yet. And this is the base pointer, which is where we're at the moment. So we come through here. We build that alignment mask, right? Like I said, it's 3, exactly what we're expecting for an alignment of 4. We take a look to see if there's any residual. There isn't, because this is already aligned to 4. So we don't add anything to the size, and we basically end up doing exactly what we were going to do, and we produce a buffer pointer that's right where the base is, right? And so I feel like that's probably working just fine, but then of course we still haven't solved our problem because we're not actually passing an alignment in there. We're just letting everything be aligned to 4, and we need those ground tiles to be aligned to 16. So let's go ahead and do that in make empty bitmap. When we do this precise here, what I'd like to do, let's go back into handmade.h. We take a look at the push size here. Now, I want to make sure we can use this VAR, make sure we can use these push sizes. We can always specify an alignment. So what I'm going to do is say that after the things that you have to specify in these macros, what I'd like to do is specify the VARgs stuff. I'd like to specify, put whatever you want at the end of this macro, and it'll just get sort of stuck onto the end. Now, if I'm not mistaken, there's some nonsense that only happens with MSVC. It's like you need to use the paste operator or something like this. Or maybe it's GCC. and it's this syntax right here. So I do not remember which one doesn't work and which one does work, whether it's VCC, whether it's GCC or MSVC. But point being, there's a special case that happens when someone might not include any additional arguments, and there's different ways that you do it. And so I believe this is the one that works on everything. It's what I remember, and it looks like a bunch of random people on Stack Exchange are talking about. I don't know, or sorry, Stack Overflow. So I'm not entirely certain, but that was my recollection anyway. And so that's the way we're going to do it for now. But we'll have to rely on some people who compile on other platforms to tell us if that's okay. So there you go. We've got our VARG spacing, and that's just, I don't even know exactly why this syntax came about, but basically it's just saying take these guys and stick them on the end here. All right, so now I should be able to say 16 there, and I should be able to run more properly, hopefully, at least that's the goal. And it looks like we're fine now, so we've stopped crashing. Of course, we're in debug mode, so those ground buffers take extra long to render. But that's actually good because now we can start to look at getting things multi-threaded, which we want to do to sort of overlap that work anyway. So hopefully we can use the fact that they take a long time actually to sort of be a little bit of a help to us in that endeavor. All right, so hopefully everyone understands how that works. It's really simple. You can do this a little bit more efficiently bitwise so that you don't have to maybe do as much work there, but hopefully it's fine that way, and it's not that frequently a called thing, so I think leaving it explicit so you can see exactly what's happening is probably a good idea. So there we go. There's the push size. All right. So the next thing that we need to address is we don't have really, when we make our transient state right now, we don't really have any notion of temporary buffers that people can use. And so the problem that we would run into very quickly, if you take a look at what happens with fill ground chunk here, right? What we want to do is we want to be able to call this thing, right? We want to be able to call a function that would do work on a queue, and we want the work that's done on the queue to essentially be this whole routine, right? We want this whole routine to happen on a queue. So in some sense, what we're looking for here is something that probably, I mean, I don't even know. I guess we could really just do the entire thing on it. I'm not sure, but I'm gonna partition it a little bit at the moment just because I'm not sure how much we want it to do. But basically, what I'd like to do is say, okay, I'm assuming that it would not be that just queuing this stuff up is not really a problem, right? Meaning, if what we did, I guess I'll take this guy back out again here for a second, right? If what we did was just queue up all the push bitmap things and then just didn't ever render them, right? We just didn't ever do anything there. I'm guessing that if we did that, we would not actually have any pauses, right? That's just my assumption. And I guess, you know what, I could also, let me go ahead and put ourselves back in here just so I could be double sure that we wouldn't have any pauses or anything like this. So get render entity basis. Let's go ahead and go back in there. And so here we go, we're walking around, and I don't feel like we've got any problems. I'll go ahead and compile in O2 as well. And I feel like we're pretty good there, right? We're definitely not hitting any of those really big, long hiccups. So I think we're probably fine there. So that's all good. So what that means is we can leave part of what we're doing synchronous, which might be beneficial to us depending on how we want to do things, because we might not want to have to lock areas of the simulation or other things like this that might be involved when we're actually pulling out this stuff. Like right now, we could totally do all of this asynchronous, but in the future, if we were looking at things like where entities were and drawing stuff like that, that might cause us to have to lock some things that we don't want to lock, or who knows what else. And so I would like to make it so that this could run synchronous, produce the sort of the thing that needs to actually get spawned, and then spawn it. So essentially what will happen is just this part right here will get pushed onto the separate thread, and then we'll be fine. And what you can see, though, is if you take a look at how this is working, you can see why this would be a problem, because right now we've sort of created temporary memory for this render group to store those commands, okay? And then we end the temporary memory block right after we do this tiled render group to output. So if this were to become an overlapped operation that's going to execute for a period of time, we can't very well release the memory for it right after we spawn that sort of task running, right? Because we'd basically be getting rid of the memory out from under it, and it'll still be using that memory, and it'll just go crash, or who knows, because it'll read garbage from there or something as we overwrite it. So what we need to do there is we need to have some way to have like a temporary storage area where we can put these things so that the background task is capable of doing it without having, without essentially getting overwritten, if that makes sense. So if we want to do that, it's not probably going to be too difficult to do. Let's just take a look at how we might go about doing that. If we go take a look at the transient state here, right? What I'd like to do is just say, well, okay, we've got the transient state and we have a memory arena in there. What I'd like to do is introduce the concept of sub-arenas that work inside a single arena, right? So basically I can take an arena and I can break it up into smaller arenas so that if I have people who are doing work and need scratch space for it, but they all need to be operating at the same time, I can just pre-segment up my memory into a couple different chunks, and they can each have a chunk and do whatever they want in there, and I know that they won't conflict, right? So there doesn't have to be any locking or any thinking about it. There doesn't have to be any overhead introduced. I know that I can just, if I have some bounds on how much space those people might need, I know I can just pre-segment and let them go, and there'll be no performance penalties for me, right? And also no possibilities for bugs with like synchronization or something like this. So what I want to do is start introducing this. So I want to have a memory arena here that's going to basically, maybe even a couple of them, which will be for ground chunk filling, right? And so we'll call this something like, this memory arena will be the ground chunk render groups or something. Arenas, ground chunk arenas. I'm not sure. But we can basically say we want a couple of these. We want a few arenas in here that we'll use for ground chunks, right? And then what I'd like to do is have some notion of a rolling count here, something that will allow me to cycle through using these arenas so that I can fill a couple of them, like I can kick off a couple of them and know that they'll get worked on, and then as they are retired, I want to be able to know when I can use another one, right? If that makes sense. So I don't have any specific idea about how I want to do that. Maybe something like this. I don't know. I mean, I don't actually... I could just even make it so that it's always just at the beginning of the arena. I'm not sure. Let me think about this for a second. Yeah. Well, I'm going to push ahead on this a little bit. But I'm starting to get a slight sense that I want to do something a little more interesting here. But in fact, I'm just going to go ahead and say this. I'm going to say that we want something that's like, a task with memory or something like that. And I want to just go ahead and put that in here, right? So it basically has an arena that it can use to do stuff. And then it can have like, a being used, right? So something that says whether it is actually currently in use or not, right? And so we'll go ahead and say that we have a, task with memory. And then we'll just have some tasks here. And I just, I want some of those. I want 4 of those or something like this. So if I have something like that, then I can go ahead and make sure that I can, create some tasks and I can kind of spawn them off there. And then I know that I can, when there are some of these that are free, I can use them. right? And we can make more of them as we need. So let me go ahead and just make a thing that creates one of those. Let's see here. So when I do this initialize arena stuff, what I want to do now is I want to say I want to be able to make a bunch of these tasks. In fact, I might go ahead and put that up here as sort of a more, right after we do this initialization. What I want to do now is actually create those, right? So I'll go through and I'll say, okay, for each task that I have, I'm going to go through and that's however many of these, array count, however many I have. And for each one, I want to initialize this thing, so task with memory. So we have a task, transstate tasks plus task index. So for each task, we're going to say that it's not being used, obviously, and its arena is going to be whatever this guy is here, this tran arena. What I want to do is have something where I can specify that I want to have a subarena, right? So I want to take that transient arena and I want to basically be able to carve out some subsection of it, right? So maybe I want my tasks to have a 1 megabyte stack effectively that they can work with, right? That they can sub-allocate out of, and so that will create that, right? That will create that subarena. And I guess to keep it in line with the way that I was doing it before, it looks like we basically point to an arena and say fill this out. And so that's what this would do here. All right, so hopefully that's pretty clear how that would work. And so when I do fill ground chunk, right, and we take a look at how that actually works, at the moment, we don't, this routine, again, is kind of placeholder. It's just kind of a silly routine. So we won't really play with how these are getting kicked off yet. We'll think about how we want to do those maybe a little bit later on. But we'll assume that once someone has called fill ground chunk, what we essentially want to do now is when we call fill ground chunk, we want to get an available task, right? And then what we want to do is our begin temporary memory, end temporary memory stuff. We actually want that to be part of the task sort of completion notion, right? So what we want to do is say, all right, let's go ahead and have maybe two things here, which is, trying to think of how to say this. So essentially what I want to do is make it implicit in how this thing works, right? That I'll just, when I begin a task, all the memory is going to be temporary because when the task is over, or that memory will get flushed, right? That's what I want to have happen. So what I'm going to do here is in my task with memory thing, I'm going to take the temporary memory, and this will just be like the memory flush or something. What I want to do is, when you say begin task, there'll be a way to begin a task here. And then there'll be a way to end the task with memory, like so. And so what I want to do is this begin temporary memory stuff here, that will not actually be happening outside in the ground chunk. That will be happening when we do the begin task with memory. So in the transient state, I'll take the trans state here. We'll do this begin task. We'll actually do the begin temporary memory somewhere else, and then we'll do this end temporary memory somewhere else as well, like so. Yeah. And so then our callback here that actually does this work, the do tiled render work stuff, that will actually happen when that actually does the work. It will call end task with memory when it's done. Okay, so we'll get rid of this. There we go. Okay, so what I want to do is I want to go ahead and say that this thing, when I do fill ground chunk, I'm going to use this begin task with memory thing. I'm going to use an if around it. So I'm going to say if begin task with memory, then we will actually do this ground buffer filling stuff here, right? And off we go. Wish I had some tissues here, but I don't. Oh well. I guess I'll just remain stuffy. You know how it is. Anyway, so we've got a couple things that we want to look at here, but I'll take them one at a time. But basically what I want to do is say begin task with memory, and only if that returns true do I actually do the work of filling the ground chunk. Okay. The reason that I want to do it that way is because when I do begin task with memory, it's possible that there are already too many tasks running. And I don't want to just launch like a ton of tasks. I only want to launch a certain amount of tasks, enough tasks that I have time to do or whatever, so I want to keep it limited. So what I'd like to do is make it so that when you go to spawn a task, you may or may not be able to spawn that task, and you just have to deal with it, right? So if you're trying to put on work into a background queue, you can't just spam it out there. You've got to actually think about it a little bit. Now, we could do stuff that doesn't involve that, like we could make it so that they just build up a work queue, but if that's the case, you know, you run the risk of like, how do you know that thing isn't growing out of control, and so on and so forth. So I'm going to keep it a little bit more under control than that for now, and just say if you know, this will basically tell you if you are able to get a task or if you are not, okay? And so what we'll do is we'll just loop in here. We'll loop over the tasks that are available. So we'll say task index from there to the task count, right? Array count, there we go. Plus task index. And what we'll do is we'll go ahead and grab one of those task memories out of there, and we'll see for each one of those, we will see if it's being used, right? And if it's being, I should say if it's not being used. If it's not being used, then we will say that we have found a task that we can use, and that is the one that we will use, right? In fact, I guess the found task thing, what I really probably want to do here is say task with memory, right? I probably want to do it this way. Instead of a bool, I probably want to just return the task, right? So there's the found task, right? And this go ahead and does found task equals task, and off we go, right? So assuming that it finds the task, it can also do it here. It'll begin the temporary memory for the task. So we have task memory flush, right? Memory flush, oops, arena. So there's that task arena. I'll basically say I'm starting a new temporary memory set for this guy. I could also here, if I wanted to, probably, I suppose this could actually be where I also do the end temporary memory. But yeah, I don't know if I want to do it that way. I think I'm going to not do it that way. Anyway, so when we find a task, we then go ahead and say we're going to start using, memory flush. We're going to start temporary memory block, so this whole arena can get flushed at the end of things. And then, you know, when we're done here and we do the end task with memory, we'll do the memory flush here, like so. Right? And that will just go ahead and flush that out. And so that's really mostly what I need to do here, right? And it will return that task with memory back to the guy so that it can do whatever it wants to do with it. And if it doesn't find one, then it's just going to return 0, right? So then when I do that, that ground chunk, I've got the task with memory. Here's my task. And so if I get the task, then I'm going to go ahead and do this stuff that I'm going to do, right? OK. So we've got some things that we'll have to deal with a little bit as well in there. We'll talk about those a little bit later. But then when we go to do tile render group to output, what we want to do is this is the thing that we wanted to put kind of on the background threads here, right? What we want to do is make this be on the background threads. What I'd like to do as well, when we do the tiled render group to output, I don't know if we have, I don't think we have any way to do it non-tiled right now. So what I'd like to do is also have it so you can see that we kind of kept it in here. We kept it so that it was possible for it to do it non-tiled still, right? So if we do tiled render group to output, we can actually do we could actually do something here where we do render group to output, and we can actually have a bool here which is like tiled, or multi-threaded or something like this, right? And what we can do is, assuming that we do want to do it multi-threaded, or if we don't want to do it multi-threaded, we can actually do it essentially both ways, right? We can have a thing that does both kinds. Trying to think of what the easiest way to do that is. I wonder if it's easier to just actually have a separate routine. I think it might be, though. So looking at it, it looks like it's actually easier to have a separate routine. So we'll leave that as tiled, I'm thinking. And go in here and say, all right, there's also just render group to output that's non-tiled, right? The way we sort of had it before. And what that does is it still does the same stuff, but now it's not going to actually do any tiles here at all, right? So it doesn't do any of this stuff. It'll still at least verify that the output memory is the same there. Let's see here. We could also assert that the width is proper. I guess the way I could do this is actually do it like this, right? Where we just say that. So keep these guys in there. Get rid of these. Still do that alignment there. Get rid of these entirely, like so. And there we go. Right. So this would be the path that does things. I guess I need one of these work guys, like so. Work. And this is just me calling it the same exact thing single-threaded, right? So we're basically just saying we want the whole region to be in the clip rect. We don't actually care. I guess this actually goes like this. So I want to pass all that, which actually now I look at it, it looks like we don't even need this tile width. It looks like that was more something that was done here to make sure that as we strided, we were always aligned as we went from tile to tile. So actually, we don't actually need this. It looks like we're just good. We just have to set up a clip rect. That's the whole screen. Screen, in this case, it's the ground buffer, but you know what I mean. And so then we just fake it, and we do tiled render work as if we were doing a tile, but really we don't ever do an actual tile, if that makes sense. So we do call this here, right? And we can even pass, because we're not using the render queue, right? The render queue could be passed as 0 here if we wanted to. In fact, I guess what we could do is do it like this, right? Just so we know that you don't need a render queue to do this. So there we go. And that, yeah, that looks more correct. So you just have the render group there and the output target. So this now needs a way of being called, again, sort of like this needs a way of being called as a separate task so that it can do everything that it needs to do. And this guy, of course, also, we never quite finished this end task with memory. This guy needs to be passed the task so that it can do this. It needs to flush the memory, and then it also needs to set being used equal to false, right? For good measure, we should probably do one of those complete things here. We would probably want to put one of those complete, previous writes before future writes kind of thing that we were doing, right? One of those read barriers. And I feel like I'm trying to think how necessary that actually is. But it seems like provided that we actually switch this to being an inline, which it probably could be because it's very small, right? It does seem like we probably want that to be in here, right? Now that doesn't actually do anything on MSVC, but it's something that we might want to put in there, a barrier. Well, and it does, like, I shouldn't say that. MSVC, it does mean something. It's just on x64 it doesn't, but it's the read barrier on MSVC. So if we take a look in here in our Handmade platform stuff, and we want to start sort of putting some things in there to define these intrinsics, right? Actually, I guess we also have an Handmade intrinsics file. We could put them in here as well, right? So in our Handmade intrinsics, we can do a compiler MSVC, and then we'll do an else where we don't actually know what this thing is yet. We don't know what it is here. We could put an error, but I'll let it compile for now and just put a to-do here. Need to define these on GCC LLVM, which is probably the only platforms that we'd actually also be compiling on besides MSVC. So in complete previous writes before future writes, we know that that's a write barrier. We know that that's this guy, right? Write barrier. I don't know why I put a T under there. I think I've been working in another code base a little bit too much. So let's keep going here. I think we've got about 15 minutes left according to the clock because we went pretty late when we were starting. So do tiled render work. We need to cannot convert argument to, right, that just needs to be an address. Already has a body, that's correct, it does. This is actually fill ground chunk work. And we have to define these, so that's all good. And end task with memory needs to take the task. So, all right, so we're basically putting ourselves in striking distance now to start doing these tasks, which is what we wanted. All right. So if you imagine what happens here, we're going to be doing this begin task memory stuff, right? And what we need to do here is when we do this allocate render group, instead of using the tran arena, right? This is where the memory was coming from. We wanted to allocate this transient arena thing. What we want to do now is we want to go ahead and allocate the render group instead from the tasks arena. So the tasks arena is what we're going to use. And we probably want to allocate for the render group, since we're not doing anything else, we probably want to allocate like everything that's in the task arena, right? Because there's nothing else. We probably want the whole, however much the task arena has. So when we do the allocate render group, we probably want to do is like get arena size remaining or something, and we'll just allocate the entire thing to the render group, because this doesn't actually ever allocate anything else. So it's not like it would ever actually need anything else to do. It's rendering. So that's fine. So then what we would need to do here inside that task as well, and I guess that's where our other allocation would come from. We would need something that allows this to do its work, right? So we would need a fill ground chunk work structure, and that would have to have the things in it here that we would actually need. And you can see exactly what those are because I've already written out what I want them to do, right? So all we need to do is actually just have a way of getting those in there, right? So, render group, we've got the output buffer. I don't even remember what this thing is. What's an output buffer? Render group, bitmap, buffer. Is it just buffer? Is that all we were rendering to? Yeah, I guess it is, just buffer. Yeah. So I guess it's loaded bitmap buffer. Yeah, I guess. Looks that way. So these are the actual things that I need, right? So if I go ahead and say that, the thing that you pass to this fill ground chunk work is one of these sort of structs that's got the stuff in it that it needs, then I can just go ahead and pull those out as it goes, and it can do its sort of like cleanup at the end. And of course, this thing has to be the last thing because it's going to self-destruct, basically. This sort of self-destructs everything, so there's no way to recover after that. Like, that's got to be the last thing you do when you do stuff. All right. So if we come down here now, well, actually, I guess we don't need to do anything in particular quite yet, but we just need to fill out one of these. That's a thing that tells, that's basically got our work request in it. And so what I want to do is take the task arena, and I want to just allocate from that first. So that task arena, I'm going to go ahead and do a push struct on the task arena for one of these fill ground chunk works. And then I have that, and then I can fill it out with the things that I need later on. So when we get down to the bottom, right before everything's over, I can basically put everything in it. So I can put in the buffer, I can put in the render group, and I can put in the task, right? So if I do that, I should be able to now do exactly what we did in the render group when we were spawning a task, where we do this sort of thing where I do a platform add entry, right? I do a platform add entry to the trans state. We've got that low priority queue that's for stuff that's happening sort of in the background. I've got do fill ground chunk work, or whatever it is, fill ground chunk work, and I've got the work order that it needs to do. So there we go. What is use an address? There we go. So now I just need to implement the other functions that I said that I wanted that I haven't actually implemented for the arena. They're actually pretty straightforward, right? Let's see if we take a look here. So here is our arena structure. We have a size and a used. So in order to do a get arena size remaining sort of a thing, there's not really anything in particular we would have to do there. We can just go ahead and compute that directly. Say get arena size remaining. There's the arena, right? And you know, the result is just going to be the used amount, right? Less, you know, the used amount is going to be subtracted away from the total size that it had, and that's how much space that there is left. Now, it's a little confusing because actually when I do get arena size remaining, technically you also need to know what the alignment is of the thing that you are going to use was. So I'm going to make this mirror it like this so that you can sort of say, okay, if we were going to do the alignment also and you know, adjust the size that way, what would happen there, right? If it was going to be aligned, because remember, alignment can eat up a little bit of that. And so, you know, if I was to do that, what I'd want to do here is essentially, I'd want this code to give me some indication. I want to be able to reuse this code, basically, right? You can see when I do this, it produces an alignment offset, right? And the alignment offset's what I do, is what I use for everything. So what I'd like to do is have a thing that's like, you know, inline memory index get alignment offset, something like that, which goes ahead and does this computation for me. And it can also do this in here, right? Like so. And yeah, so then result pointer, I'd have to in here, I'd have to also do this operation again. So base pointer used. Oh, you know what I could do too? Well, no, I don't really need to do that. So we can basically do it this way, right? And that should, I think, work. Yes, that'll work fine. So actually, this will just work now. There we go. So if I do that, and I have get alignment offset, I can now make sure that I always account for that when I'm doing operations that involve thinking about the size, because this will come back properly. And so then I guess I need to do this equals get alignment offset arena. Then we grab the alignment offset here to add to the size. I didn't mean to copy that out. And so this just needs to return that alignment offset. And now what I can do is say that the result is going to be, you know, the arena size equals this minus the part that's used plus any amount that it would take to move me up to the alignment that the person is trying to ask about, right? Oops, that's not what I meant to do. Too many errant keys. Okay. So there we go. And we just need the alignment offset now to be initialized to 0. And we should be good. There we go. And this takes the alignment. So does this. Oops, not the alignment offset. And off we go. So this needs an address on it. And conversion from size t to uint32, possible data loss. Is that so? Is that so? Tell me, who is saying this is true? Get arena size remaining. Where is that? There it is. It's producing a memory index. Memory index is, it's all of doing memory. So who is complaining about this? Argument conversion from size t to uint32. Of course, it doesn't actually tell me who it is, so maybe it's allocate render group that's complaining about that. Probably is. Let's go take a look and see what allocate render group is expecting to see. That is exactly what the problem is there. So let's go ahead and make that a memory index. Okay. And these guys should be as well, I suspect. Oh, well, you know what? Now I think about it, I don't know if that's actually true, because do we really want our max push buffer size to be uint30 to have to expand to be uint64s? Probably not. So I think actually what I want to, I think that's not actually what I want to do. So I think I do actually want to cast this. So I think what I'm going to do is something like, you know, uint32, you know, cast this to uint32. I'm a little bit nervous about that because I want it to be a saturation here. You know, what I want to do is I want to do like, you know, something where I'm going to do either the uint32 version or FFFFFF if it's over. I'm gonna say also to do here safe cast from memory uint to uint32. It won't be a problem at the moment, but I'm worried that eventually it might go over or something like that, and then we would be sad. All right, so subarenas are very straightforward. These are really, really easy for us to do. So if I come in here and I want to make one of these subarenas, all I have to do is say, okay, I've got a memory arena. I want to make a subarena out of it. So I pass in the main arena, and I have the result. The result is going to be, let's see here. So the result size is going to be whatever the size is that's passed in, because subarenas have to have sizes. So there's the memory uint, right? Size. So there's the size. The result base is going to be me pushing that size, right? And I guess I probably should have an alignment here as well, right? A base alignment. Although I could just force all of these since for subarenas. Subarenas maybe want to always have an alignment that's like going to be the full alignment, you know? So I don't know how true that really is that we need that to be in there. I don't know. We'd have to think about that, but I'll leave it just as a big alignment for now. So yeah, so we've got the size in there. We've got the base, which is going to be us grabbing that amount. We're going to have the used, which is none, and the temp count, which is also none. So actually those can just remain uninitialized, and that's a subarena. That's all we need. That will basically create a subregion that gets sub-allocated out of separately. So memory index, that's what I actually wanted. Don't know why I said memory uint. Probably should. Memory uint's a little more descriptive. Anyway. Oh, but it's not a uint. I guess it's actually memory int. Well, either way. Okay, so let's see. Push size comes back. I gotta make this be a uint 8 pointer. That's fine. We've got our subarena happening here. Oh, right. I said that I wanted this to be this way, right? Because I want it to be mirror the way the other one worked. So that's fine. No big deal there. But if we do that, that means we have to initialize all the variables. So we'll have to do it like that. Okay. So I think that's just about all of it. Unfortunately, there's still there's still a bunch of stuff. We're just about out of time, but there's still a bunch of stuff that we haven't quite covered yet in terms of how we would probably want to button these, task things up. But we're sort of getting, you know, we're getting a little bit closer to having something where we can just use it to do generic work instead of, you know, only that sort of very specific render workload that we designed it to do. But hopefully you can kind of see how this is starting to work out, right? So, you know, when we come in here to fill ground chunk, what we're doing now is we're using this separate arena that we have just for this particular task that we're going to launch off. We put everything into that, and then we go ahead and say, hey, put that in a low priority queue, get to it when you get to it, and we're all fine, and then we leave. And so we can queue up 4 of those at a time, and they can just be doing whatever it is that they're doing. And then when they're done, they'll get released back to the system by saying that they no longer do anything, by using this being used, taking that out. It's not anything fancy at the moment, but it should put us into a situation where we could actually debug it and get it working. At least that's the theory. Okay, so what am I looking at here? I don't know what I'm looking at here. Hold on a second. Not sure whether we should start debugging this or whether we should try to do it tomorrow, but let's take a look. All right, so I'm having an issue here where my chunk is a nonsense situation. Let's take a look here. Should probably compile in debug mode. Yeah. All right. So let me take a look at where we're at here. I am in the middle of the add wall stuff. So this is just coming through. So I obviously broke something because this has nothing to do with our threading. When I was doing the arena stuff, I obviously broke something with our arenas because you can kind of see in here we haven't actually done any of the ground chunk stuff yet by the time we come in here. So this is actually just some kind of separate, some kind of very separate error. So I probably broke something when I did the alignment. So I'm just going to go in to push size and see what I broke because I did that pretty quickly and I probably just ruined it. So let's see here. Alignment offset is 0. That's good. The size is something, so that's going to happen. We go ahead and do that. We generate a result pointer and we come out. What's that allocating? The world. Let's take a look at the world. So that just totally failed, right? Oh, wait, no, sorry. So that's all good. Chunk dim in meters looks good. The chunk hash is there. There's the chunk hash. Everyone loves the chunk hash. So we come through here. We're calling push size again. What's the alignment offset now? It's nothing again. That's good. Size is all good. Arena used. Let's see what we're looking at here. So we've used some of it. We're still using some more. Off we go. This all looks pretty reasonable. Okay. So let's come out here and see. Load in some bitmaps. That's all good. So now let's take a look at our game state. So let's see what we're looking at here. Here's that world arena. It hasn't really gotten filled up at all yet. It's still got plenty of room. And so in we come here. Add standard room. And when do we start crashing? We don't crash for a while, actually. So we're adding walls just fine. You know, off we go. No real big deal. And we're adding walls, we're adding walls. So what does it look like when we actually get to the point when we crash? Add grounded entity, add wall, game update and render. So it's not like we're out of space or anything. We have plenty of space. And we're looking at some stuff that looks pretty valid. We come down into add wall. We're adding a grounded entity here, which is just our way of adding something that has collision with it, right? So we've got our entity low happening. Change entity location. So that's taking a look to see if it's going into a place. It is. So it goes ahead and does that. It does get world chunk. The chunk comes back. The chunk comes back okay. So that's fine, actually. And, well, no, I shouldn't say that. We're inside get world chunk at the moment. The chunk location is all good. But the chunk hash plus the hash slot is not. Well, it could have been because of the next in hash as well, I suppose. We don't actually know. which of those it did. Let's take a look. Hash slot is 3. So world chunk hash plus hash slot. So that's valid. It's next in hash that is not valid, right? That's totally bogue. It's totally bogus. So I wonder if this is messing up. I'm just going to go ahead and see if it does. So that was not the problem, as far as I can tell. So all right. Next thing to try, when we do our push size, I'm going to assert some things here. So when we're done doing our push size, I'm going to assert that the size, so this thing, I'm going to do a size init, right? So the initial size. So take the memory index here, size init, right? Like so. I'm going to assert that the size is greater than or equal to size init, so we're reserving at least as much memory as was requested of us. Oh, nice. That's lovely. Well, that would do it. That's great. I don't know what to say about that, but you saw the problem there, right? I put the thing that advances in the wrong spot. I don't know. Yeah, that was pretty dumb. All right, so let's see here. Where are we at? We've got an assertion. You can allocate render group, max push buffer size. So this is the max push buffer size, but it also needs to take the struct into account. So I'm going to go ahead and say that when you do allocate render group there, allocate render group, let's see, handmade render group. How can I do this? I want this to basically allocate, to take into account that max push buffer size. I want it to take into account that it needs to not have this in here. I could have it subtract, but then the meaning of this means something else. I don't really know. I'm not sure what I want to do there. I'm not sure. So maybe if you do allocate render group and the max push buffer size is 0, then it does the one for you. That's kind of janky. I don't love that. But you could do this, right? If max push buffer size equals 0, max push buffer size equals get arena size remaining. That I don't love it, but I didn't see a lot of other options at the immediate moment, right? So that's what we're going with. That's what we're going with. Okay, so let's see here. Push struct, fill ground struct, task arena. So that actually looks like we're almost running here. So I don't know. I'm sorry about taking up too much of the Q&A, really. But I kind of wanted to see I kind of wanted to see how far away we were, and we don't seem to be that far. So if I take a look at the task arena here, it's all filled up. And it looks like the temp count is 2, so it's like it never did the end here. I never set it to being used, did I? That's kind of stupid. So that's obviously not going to work either. When I do begin task with memory, obviously I need to mark the task before I return it. I need to say that it is being used, right? Otherwise, it'll just be tried to use again. All right. All right. So anyway, yeah. Anyway, let's go ahead and see now how we're doing here. Let's take that build.back and change it to an O2. Go ahead and run. So now we've got some stuff happening in the background and rendering. And like we're not really giving it enough of a lead time to always hit. So we've kind of got a problem there, but we've seemed to have taken care of our really long stalls, so that's good. And those ground chunks are rendering in the background now, which is what we wanted. So yeah, so that's good. And we can also go ahead maybe now and ping back over here. Now that we have those operating in the background, we can also sort of come in and change that get render entity basis to be debug style. So here we go. So yeah, basically all we really need to do now is query a little wider, and we should be pretty much good to go on the background tasking, right? Background tasking. Yeah. Yeah. All good. So like I said, we got a couple things we didn't cover. Like right now, we're drawing from those bitmaps at the same time that we're writing into them, which is not super cool. Because we don't guarantee that they're actually done before we start blitting them. So we probably want to put a little trap in there, something that says, hey, I've been finished. And if that's not set, like don't draw me, because that would be bad, right? So, stuff like that. But yeah. So hopefully you can see that working pretty well now, and we've gotten rid of our hiccups, so we're maintaining a nice smooth frame rate, which is what we want, no matter what the situation is. So that's all good. So let's go ahead and do a quick Q&A. Don't have a lot of time, but we'll do a little bit at least. Let's go ahead and switch to Q&A. I'm glad that the Handmade Hero bot actually listens to my Q&A requests now, because before it definitely did not. Let's see, does anyone have any questions about what we did today? Does anyone have any questions about what we did today? If one of the tasks with memory, which has several tasks with memory in front of it, calls n tasks with memory first, will the stuff in front of it be screwed up, or this case is not possible? Because I have a feeling that I don't understand something. I think you're thinking about what would happen if all of the tasks were using the same arena, but they're each using their own arena. So here's what actually happened, just so you can see. Here's the transient arena. Mischief, please keep up with me. Waiting for you. There we go. So this is the transient arena, right? And this is allocated on startup to be some giant, it's like how much memory is in the machine, we'll take it all, right? So I don't know, give me 4 gigabytes, however much you got. What's the player got in there? We're gonna use it for something. We'll find something to use it for. So we allocate the memory that's in the machine, and now we're gonna divide it up, right? So first we put some stuff in there, right? Like, some stuff gets loaded in here. So this is other things, right? Who knows what they are? The actual trans states in here at the top, right? But other things, whatever. Then, and the ground, like there's the ground chunks themselves are stored in here, right? The ground chunk bitmaps are stored in here. So we do this stuff. And then what I did is I said, oh, okay, I'm going to slice this part up and make some separate arenas, right? So this is task 0's arena. This is task 1's, this is task 2's, this is task 3's. So these arenas are actually totally separate. So all 4 tasks can be totally asynchronous and happen in any order. They get their own memory playground to play in, so they don't need to talk to anybody. They don't need to synchronize with anybody. They can do whatever they want as long as they do it entirely inside this arena. So when we go to kick off a ground chunk, we stick all the render group stuff into the arena for the task that's about to get spawned, right? We then spawn the task, we let it run to completion, and then when it's done, it just sets a little marker, right? So remember up here in the trans state, we have those being used, right? Say whether the task is being used or not. We have those. It just sets one of those little being used things to 1 or 0. It sets it to 0 so we know that that one is no longer being used. And every time we go to kick off a task, we just look for one of these that has its being used set to 0, right? And if we find one, that's the one we kick off. So everyone's totally segregated memory-wise, and that's why we don't have to care who ends first or whatever. It doesn't matter. We already had memory reserved for the ground buffers. Why couldn't we just use that memory for the threaded stuff? Well, that's where the bitmap goes. So we can't use the same memory for the bitmap as we use for the render group, right? And also, we have a lot more of them, right? So there's something like 256 ground chunks, I don't know, 128 ground chunks, right? Right? There's 128 ground chunks, and that's the memory for the bitmap. It's a 256 by 256 bitmap, okay? So where were you going to put that render group stack? Which I don't know how big it is. Let's, 10K or something. Where were you going to put that? You can't put it in here because this is what you're rendering to. You'd overwrite the render group in the act of filling in the bitmap, right? If you stuck it on the beginning, then all 128 ground chunks get bigger by whatever that is, 16K, who knows how much it is. Get bigger by that, even though we'll only ever use 4 of them at a time. So that's a huge waste of a ton of memory, right? So we don't want to do that. So what we did is we made memory for the chunks we made memory for the tasks themselves per task so that things that only live the lifetime of a task can go in there and not take up permanent storage in things where there's a lot more of them. What are the lines on the screen? Let's see. Why are there lines on the screen? Are you talking about these lines? These are in our debug mode so that we can see this is where the camera would see, this is where the simulation region is, and this is where the outer bounds of collision consideration are, right? So the user never sees any of that stuff. The user sees this, right? This is how the user actually sees it. And of course, this yellow line would not be there. That's the yellow line that's showing the camera bounds, right? Yeah, if that makes sense. That actually reminds me of something. When we do Handmade, that I wanted to see. Stretch DI bits. Let's see here. I'm not sure. I feel like, is that the edge? Well, I don't know. I think we have some kind of weird thing. I guess I do have some kind of weird alignment bug or something. I feel like we shouldn't be seeing that unless we're calling this. Are we calling this path? Why would we be calling this path though? If window width is greater than or equal to buffer width times 2, I feel like we shouldn't be calling that path, right? But let's find out. Let's find out if we are or not. So I'm going to change it to only have an offset there. Nope, that's it. So we're calling the wrong path. I don't know why. Is the buffer width set to... Oh, the buffer width is probably rounded up now. Or something like that. Oh, no, it shouldn't be, though. Yeah, I don't understand. If the window width is greater than or equal to the buffer width times 2... Oh, I see. It's because, actually, this is just the case for stretching, which we didn't want to do. And so, okay. Never mind. I was just confused there for a second. So really, yeah, like really what we want to do is we need another path here where they're equivalent. So I'm going to go ahead and just for now comment these out until we do something smarter here. So we'll just go ahead and actually, I guess I'll do it this way. Yeah, I was wondering what was going on there. It's kind of annoying. I think Chris Hecker was mentioning it too. He was like, "Why are there black bars?" And I'm like, we've got the Windows side code is doing some stuff. So let's go ahead and get rid of those. There we go. So now, as you can see it correctly, that's the yellow boundary that we were looking at when we zoom out. That just shows where the camera's going to show. So you basically constructed a task pool for ground chunks to run on another thread. Can you use this mechanism for other types of tasks as well? Yes, that's why I did it that way. So we can put back any kind of background task we want on there. And of course, the renderer also runs through that same task system, but it just doesn't need the temporary storage. It's an immediate thing. So that's why we never had to make any temporary storage for that. Why not put the stuff at the top of the transient arena into the permanent storage? Ground chunk bitmaps. Because they're not really permanent, right? They can be recreated at any time. So we could actually throw them away if like the operating system says you need to go into a low memory state or something. We can throw them away and then recreate them. That's why they're transient. Why does it flash magenta once in a while? Is it because we're drawing without the work being finished? Yes, that was the thing I was saying before, where we probably want to do that locking there. Although technically we could just never bother doing the locking because our goal should be to always queue up those regions before they'd ever be seen. So you would never actually get into that situation in the first place. But yeah, that is what's happening right now since we don't ask for them early enough. All right, looks like we're done with questions. All right, so I will wrap things up. I will wrap it up. Okay, let's close down. Close it down. Save everybody's favorite mischief. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. We now have a bunch of things that run multi-threaded, and that's kind of cool. We've shown both how to do optimization with multi-threading and also how to get rid of lag with multi-threading. And so we kind of got both of those working now, and that's pretty cool. And they're both working through the same very, very simple task system we built in the operating system. It's just a few lines of code in the operating system layer, so that's very satisfying as well. It just shows you don't need a whole lot to build multi-threading. It's actually very, very simple if you just don't overcomplicate things for yourself. So that's the good news. The bad news is we still have more to go. Because we got to go look now at some other renderer Z stuff. So we still have more work to do before we can call our rendering stuff done. So we want to go work on that, and that's what we will be doing tomorrow. And I hope to see you here for that, same time, same place, 5 p.m. Pacific Daylight Time on Twitch. And I hope to see you all there. In the meantime, if you would like to play around at home with the source code, if you pre-order the game, it comes with the source code. So if you go to handmadehero.org and pre-order the game, you can download the source code and play around with it at home, which is great for learning or doing whatever else. Just if you want to sort of experiment with it, go nuts. Anyway, we also have a forum site where you can go to ask questions, and you can also get ports to Mac and Linux there that community members have done if you're trying to do that yourself. That's a good place to check that out. We have a Patreon page you can go if you want to support the video series. You can subscribe there. And also, if you want to know what the schedule is going to be because you're trying to catch it live, we have a tweet bot that'll tweet the schedule at you, so you can go ahead and follow him. And he will take care of things. Or maybe it's a her. I don't actually know the gender of the tweet bot, to be completely honest with you. All we really know is that it's going to eventually become sentient. You know, when people like Ray Kurzweil talk about the singularity, that's what they're talking about. They're talking about the tweet bot, the Handmade Hero tweet bot, which will eventually become sentient, be able to self-modify, replicate, and destroy all of mankind. But until that happens, like I said, we'll be back here tomorrow, coding Handmade Hero in an event to try to finish a nice game engine and a nice game on top of it before the tweet bot becomes sentient and destroys the world. So I hope to have your help for that. I'd love to see you here. Have a great time until then. Take it easy, everyone, and I will see you tomorrow.